Hi, welcome to an Arduino step-by-step course by Robojax. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. In this lecture, we are going to learn about the sound module or sound detector. In this lecture, we are going to see how we can use the sound module with the analog output that have been connected to analog 0 to control AC bulb without going through the sensitivity of this module. In this lecture, we are going to learn about the sound module or sound detector. This module has a microphone here that picks up the sound surrounding this module, especially from the forward, but it has a pattern that it can pick up the sound from everywhere. And then the sound is being amplified, and the sensitivity of this microphone is adjusted using this multi-turn variable resistor or potentiometer. This is a 104 100 kilo ohm potentiometer, and the output, the detected output, will be sent to Arduino, and based on the detection of a signal or sound, we can take some action. Or maybe with a shout, light off. When you work with AC power, touching this while it's connected to high voltage will cause electrocution, and it's very dangerous. And we have here 4 pins. The last pin here is digital out, and then we have the plus. This is a VCC or 5 volts, and then we have the ground, and then the last one is analog out or AO. Digital out will have either high or low, which you can connect it to any of the digital pins to control something, and the analog will have variation of sound that is picked up, and you can set the sensitivity at what level you want to take action. We have 2 LEDs. One LED or light indicator is here, the other is here. This is the power LED. Once you connect the power, this will turn on, indicating that the module receives power. The other will turn on when the signal or audio is detected, and the signal goes through this DO pin. This module, you might receive it sometimes with a smaller microphone. The microphone might be pointed up, but you can change the direction, whichever direction you want. Let me explain now the code for the sound module. First, we define pin 2 as sound in pin. This is where the digital out of the module will be connected, and then we define pin 8 for relay pin, and we are creating extra 5 volts or secondary VCC for the relay or for the sound, doesn't matter, so we call it extra 5 volts. This is pin 12. Below this line, do not change these. These are the values to keep the light on. For example, this will store the value for the pin 2, and this will store the status of the relay, and this one if the audio or sound was heard. So these are used internally. These are used internally for the code, not for the settings. And inside the setup, we do execute these codes once. First, we define the serial monitor with 9600 baud, which you can open the serial monitor from here, and the 9600 is in here at the bottom. And then using pin mode, sound pin as an input, and then we use pin mode sound in as a pull-up, because this module needs a pull-up resistor. And then using pin mode, we define a pin for relay pin as an output, and also extra 5 volts pin as an output. And then immediately after this line, we use digital write extra pin as high. This way, this pin will always have 5 volts for our module. Inside the loop, we use digital read sound pin. This is pin 10. This is a pin 2, and the value of the pin, whatever it is, will be stored in val, which have been defined at the beginning of the code. And in this portion, we check if that val is equal high. These two ampersand mean and means this is true and this must be true. This and means this portion must be true and this portion must be true. So we check if relay is equal low, and here we check if relay on is equal low. Then if this are then if both of these are true, we take if both of these are true, what we do is we change the if both of these are true, we change the value of hertz by using 1 minus hertz. For example, if the hertz was 0, 1 minus 0 will be 1. Repeat this portion. This portion will say if value is equal high and these two ampersand mean and relay on is equal low. So this portion and this portion, both of these must be true in order for this condition to be true. And here we change the value of hertz, which have been defined at the beginning of the code. This is used here. And if the hertz was 1, so what we do is 1 minus this hertz, which is 1, it will be 0. So the hertz will now have 0 value. If the hertz was 0, now check here, 1 minus 0 will be 1. So now the hertz has been changed. So this is a mathematical way of changing value of a variable, and then we wait for 100 milliseconds. Then the value that we have read here, we are storing it in the variable called relay on here. And here we check hertz. If hertz is equal high, then we print this text on the screen which says light on, and then using digital write we send the low signal to the relay to be turned on. The reason for sending low is that the relay module that I'm using is low trigger and it will turn on using low signal. If this is not true, then else we print this text relay, then we print this text light off, and then we send high signal to the relay pin. This way the relay will be off, and then we wait 100 milliseconds and the loop will continuously take the same action, and the loop will continuously do the same thing. Below this line, do not change these. These are the values to keep the light on. For example, this will store the value for the pin 2, and this will store the status of the relay, and this one if the audio or sound was heard. So these are used internally for the code, not for the settings. And inside the setup, we do execute these codes once. First, we define the serial monitor with 9600 baud, which you can open the serial monitor from here, and the 9600 is in here at the bottom. And then we use pin mode sound end as a pull-up, because this module needs a pull-up resistor. And then using pin mode, we define a pin for relay pin as an output, and also extra 0.5 volts pin as an output. And then immediately after this line, we use digital write extra pin as high. This way this pin will always have 5 volts for our module. Inside the loop, we use digital read sound pin. This is pin 10. This is a pin 2, and the value of the pin, whatever it is, will be stored in val, which have been defined at the beginning of the code. This portion will say if value is equal high and these two ampersand mean and relay on is equal low. So this portion and this portion, both of these must be true in order for this condition to be true. And here we change the value of hertz, which have been defined at the beginning of the code. This is used here. And if the hertz was 1, so what we do is 1 minus this hertz, which is 1, it will be 0. So the hertz will now have 0 value. If the herd was 0, now check here, 1 minus 0 will be 1. So now the herd has been changed. So this is a mathematical way of changing value of a variable, and then we wait for 100 milliseconds. Value that we have read here, we are storing it in the variable called relay on here. And here we check herd. If herd is equal high, then we print this text on the screen which says light on, and then using digital write we send the low signal to the relay to be turned on. The reason for sending low is that the relay module that I'm using is low trigger, and it will turn on using low signal. If this is not true, then else, then we print this text light off, and then we send high signal to the relay pin. This way the relay will be off, and then we wait 100 milliseconds. The loop will continuously do the same thing. This is a tabletop AC bulb, and this is a plug that you plug it into the wall and the device will turn on and off. And I have cut one of the wires of this, twisted them and soldered them, and this will be connected to relay. And the job of relay is to connect this and turn on the light, and this connected to turn off the light. And this is the wiring for the sound sensor. The digital out have been connected to pin 2. The plus or a VCC pin have been connected using white wire to 5 volts. The ground or G pin have been connected using this gray wire to the ground. Pay attention here, AO analog out have not been used here. For the relay, the in pin of the relay have been connected to pin 8. Ground have been connected to the ground, and pin 12, which we have defined it as VCC2 or extra 5 volts, have been connected to the VCC of relay. And here for the AC, one of the wire have been connected to this pin, and the other wire that I shown you will be connected to this, and AC bulb is here. This is the actual wiring. From the right, DO or the digital out have been connected using this purple pin to pin 2. The second pin is plus, have been connected using white wire to 5 volts of Arduino. The third pin is ground G and D, have been connected using gray wire to the ground of Arduino. For the relay, the right pin is N. This has been connected using brown wire to pin 8. The middle pin is ground, using this black wire have been connected to the ground of Arduino in here. And the last pin in this side is VCC, using white wire have been connected to pin 12, which this pin have been defined in code as VCC2 or extra 5 volts for this relay. The 2 wires of bulb have been connected to these 2 pins of relay, which have been explained before. Here is a demonstration. The Arduino is now on, the code is running, and it shows the light is off. As you can see, the relay green light is also off. It's showing that the relay is not receiving any signal. And also this is a sound module. The light for the sound is also off. It doesn't show anything detected. And now I can clap. Now because I put the sensitivity low with my current sound, it will not trigger, and the light is staying on until it receives again another strong clap or sound. As you can see also on the screen, we see it shows the light is on. To turn it off, I have to clap again. Now it's off again. My sound will not have any effect, and now I can shout, because with a normal conversation it will be safe to just keep it off. Light! And then to turn it off, again say light or another sound, it doesn't matter, it's not speech recognition. Any loud sound will turn the light off. Now, light! And then you can increase the sensitivity by turning it clockwise. Now, as you can see, even with my current conversation, it turns on and off. It just detects anything that I say. It will be either one signal. Now it's off. If I just say something higher, a little, you see, on and off. So this will not work for you. You have to change it and reduce the sensitivity. Counterclockwise will reduce the sensitivity. I'm just going a little. When I turn it, it becomes, you see this blink? The blink shows that it's getting my voice, but the output is not triggering. Thank you for watching. This was how to control an AC bulb using sound module. In this lecture, we're going to see how we can use the sound module with the analog output that have been connected to analog 0 to control AC bulb without going through the sensitivity of this module. As you can see, the light turned on with the lowest sound that I had, and if I shout a little, it will turn off, and I will explain it now. Using analog has one advantage, that instead of setting the value of sensitivity from here, you can also set the sensitivity further using analog value, and that way you can have a precise control over at what level the relay should be turned on or the signal should be detected. This lecture requires you to watch the previous lecture, which was explaining this module with a digital out, because in here we will go very briefly through the explanation. Here let me explain the code for sound sensor using analog out. Here we define analog out as a sound in pin, and pin 8 is for relay, the same as before. Pin 12 is extra 5 volts, the same as before. We have just changed this to analog 0 instead of 2. And here we have another value that we set the value of sound level or value of sound. This is through experiment. I found that 525 would be the right value for you, depending on the environment that you are in and depending on the sound module. You have to experiment and see what value is suitable. These values do not change them, they are used internally within the code. And inside the setup, relay pin is an output, extra 5 volt is another output, and immediately extra 5 is high, so we have extra 5 volts. As you can see, for analog we do not define it because analog is always input. In the loop, using analog read, we read the sound pin, which is analog 0, and the value, whatever it is, between 0 and 1024 will be stored in val. And here we check if val is bigger than sound value 525, which I mentioned above. If it is, then it will be true and light on is equal low. This will be the same as before. This is used to keep the light on or keep the light off. Here, if heard is equal high, this is the same exactly as before. We turn the light on, and also we print the value here. So this way you can learn at what value the system works. Let me show you. Right now I'm talking, it shows 520, as you can see. Hello, hello, and it goes high. And this will turn on the relay, otherwise it will turn off the relay, and the loop continues like that. Now this is the analog out wiring. This time we have not used the digital pin out, and we are using the analog out. All the other wiring is exactly the same, except the analog out have been connected to analog 0. For the analog, the only changes that I made was the wire that was here for digital out have been moved from here to the last pin, which is analog out, and this side, which was connected to pin 2, now is connected to analog 0. The rest of the wiring is exactly the same as before. Here is a demonstration. This shows the sound level that I talk. If I'm quiet, you will see it, you will get around 517, let's say 516, 517, and when I talk, it just goes above some value around, hello, about 23 or something. So this is the sound level, and we can send the sound level in here, at what level it should trigger. Now I put it at 225, and as you can see, this is not affecting it, and you don't hear any click, which means the sound level must be high enough to turn this on. So now let me just say something, or hello, hello. Now because the sound level reached, let me stop the scroll. You can see when I was shouting it reached 530, and because that was above 525 the light got on. And again, to trigger it we have to be loud enough to turn the light off. So either we can have a clap. You see the clap doesn't go that high. Light off, and when we reach above that level it will turn on and off. And this way you can have direct control. And this potentiometer, actually, this potentiometer, let me go to the right. As you can see here, the potentiometer also shows this is the maximum that is coming from this at the moment. So we don't want to do that. And hello. And if you go very low, this is what happens. Now let's see. The clap went on. Thank you for watching. This was how to control an AC bulb using sound module. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.